Good afternoon, friends and neighbors. This is part two of our dual processor GPS locked frequency standard. In this part, we're going to go through the master program, the master sketch that the Arduino people call them. Being an old timer, I refer to them as programs. Some of the more modern people even refer to some of this stuff as apps or applications. I don't know. It's tough to keep up with all this new stuff when you're a real old timer, like the old kid here. Anyway, all right, we're without messing around too much here. We'll get into taking a look at the master program, and I'll explain that to you in part two. And when we're finished with that, we'll go to part three and we'll do the slave program. All right, if you put this video in full screen mode, you should be able to see this okay, I believe. So we'll talk our way through the programs. There are two of them. There's one here for the master and one for the slave. And I'll read you a little bit here in the beginning that it's the GPS locked frequency standard frequency generator of July 16th, 2014, from a project initially published by Skullcom Hobby, and that was published on February 14th, 2016. There's a link to the original of the first of, I think, about 5 short videos that Jerry did on the original 2 projects that he did. And if you want to do this project, it's probably required watching before you get started. You'll get a real good feel for what's happening and how everything works. This is the dual processor version by yours truly. And right here we have the sketch for the master processor. We call him the master processor and the slave processor. The master is actually the boss that's in charge of running the whole show, and the slave processor sits and does what the master tells him to do for the most part. So master runs the LED and keypad to enter and display the commands and data, and communicates with the slave processor. His job it is to listen to the streaming data from the GPS module primarily. And of course he also sets the frequency on that module for the output frequency whenever the master sends him new data for that frequency display and generation. So at the beginning we include our libraries, Liquid Crystal I2C, because we're going to run the LCD on the I2C interface to the LCD itself, the screen. And then we're going to have to include the keypad library and also the wire library so we can run the I2C. Then we have the I2C anything, which is a real nice library written by, I forget the fellow that wrote it, but it allows you to send anything over I2C and not have to worry about the format length or those kinds of things. It's very nice facility, very easy to, much easier to work through with I2C with that than it is without it. Let's see, the LCD and slave processors are on the I2C bus, and nano pins A4 and A5, Uno pins SCL and SDA. So it depends on which processor you're using. Now this, you could also use a mini, Pro Mini for this, for the 2 CPUs, or one or the other, but actually the Nano is the cheapest one, cheaper than the Mini, so I get them for a couple bucks for project, for when I want to use a bunch of them. I think about $2.50 a piece or something like that from our friends in China. So it's not a big expense. The Minis are $4 or $5, I believe. I've got some of them here, but I don't use them very often because they're not that much smaller than the Nano, and the Nano is a little more convenient in its pinout. So I usually use the Nano in these kinds of projects. Uno is just too big in general purpose, so I use that for some experimentation. But when I want something that's a little more dedicated, the Nano is it. Maybe the Nano is the way I go. Okay, we have our slave address there of X10 or 8 for the slave processor, and it's 0, of course, for the master. And we're going to use digital pins right now, 511 for the 4x3 keypad. We could switch that also to the I2C bus with a chip driver, GPIO expander, but we're not going to bother since we have plenty of Arduino pins left. We needed them when we had everything hooked up to directly to the Arduino, but now we have a few pins left over actually, so why bother? That's a little more parts count if we do that anyway. We'll put our pizza buzzer on digital pin 12, and pin 2 is our master, is our interrupt. That's interrupt 0, and it's on pin 2. With that, what happens is the slave will send out a signal on digital pin 2, and that'll interrupt the master, whatever it's doing, and the master will be alerted that the slave has some satellite data to send it. So it'll post that fact, and then as it goes through its main loop, it'll check to see if there's been a post. If there has, since the master has to run the I2C bus, he can initiate a reception from the slave, and the slave will send that data over to the master. The slave can't initiate the data transfer itself, but it can certainly post the fact that it has data to transmit, and that's the way that works. And let's see, we have the liquid crystal on the LCD on the I2C bus, I2C, whatever you want to call it. And in the beginning, we played the Nebraska fight song, and here's a little definition of that with the notes and the pauses, quarter note and half note. You don't have to worry about that. You probably won't want to use that unless you're from Nebraska. I would imagine that Colorado, Texas, and Penn State folks want to get that out of there as soon as they can. We start with a frequency set of 3.333 kilohertz. And that's Jerry did that too, so that's our set frequency, which in the beginning defaults to that. And our display frequency, the frequency itself that we'll display while we're entering the frequency. And some resistor values for the voltmeter to monitor the voltage on the battery supply if we power this thing by a battery. And that's the same code, the same setup that Jerry had. It's not been touched at all. I don't have the battery hooked up here in the breadboard setup, and I don't have this circuit in there either, so I didn't play around with it at all. So those are also the float resistor divide factor and all that's tied in with that reference voltage setup. And here's a string of the satellites, number of satellites detected. That'll be sent to us by the slave when it detects a change. Every time that slave reads a GGA record, it's not going to send us the number of satellites in that record unless it's changed from the last time it sent us a number. So that cuts down on the number of interrupts hitting the master. Just a little efficiency kind of a thing. But these processors are loafing along during this whole process anyway. It wouldn't hurt to let it interrupt every time, but why should you do that? It's in the matter of efficiency. Why? And back in my mainframe days, I would do it this way, so I just continued. All right, here's some of the part of the routine Jerry did to display the frequency, megahertz, kilohertz, or hertz. The original version didn't do that. Jerry's second version did, and that's a nice change. You, just like with his system, when you enter the frequency, you have to do it in hertz. So if it's 5 megahertz that you want to enter, it's 5,000,000, 5 million. That's just the way it is for now. That could be changed, but what the heck, it's good enough. And let's see, we have here's our custom key input byte we get from the keypad when somebody presses the keypad button. We've changed it from Jerry's version. We had a 16 key keypad, and we went back to 12 because we don't need those extra A, B, C, D buttons anymore. We have the numeric keys to enter our frequency, and the asterisk key alerts the processor that the master processor we're going to enter the frequency. It responds and says, okay, go ahead. We enter it. When we're finished entering it, we hit the # key, and the master says, hey, great, I got a new frequency, and he alerts the slave, sends that frequency over to the new frequency over to the slave. The slave says thanks, and simply relays it on to the GPS, and the GPS resets its output frequency. Pretty cool. Pretty cool. And of course the master displays the new frequency on the LCD, and away we go. This defines the row pins and the column pins. Had to play around with that a little bit on the change, but that's pretty easy. Anyway, the setup on these 4x3 keypads is kind of screwy, but there they are. Those are the rows and the columns, the pins that we're using on the Arduino. And we go down to a Boolean event or a frequency. When we hit that asterisk key, we set this entering frequency to true. So now we know that we're entering a frequency and we want to get only the digits. So once we've entered them, hit the pound sign that says it's entered. We'll turn that back to false, and that helps us control what's going on without getting all mixed up and doing different things at the wrong time. And we have a Boolean post from the slave. When the slave decides to tell us he's got something ready to send, a new number of satellites, he'll interrupt, which is interrupt 0 on pin 2 of our master's Arduino, and the only thing we'll do in that interrupt to make it very fast and not interrupt it for too long is we simply flip this Boolean post from slave to true, and then go back about our business. And as we go through our master loop, next time we go through it, we'll say, is Boolean post from slave on, is it true? And if it is, we say, hey, great. We'll fire up the master. We'll send him an I2C message, I2C message, to send us the frequency, the new number of satellites, pardon me, and he'll send the number of satellites, and we can calculate whether or not we have a lock or not, depending on that number of satellites. If there are no satellites, there's no lock, and if we have one or more, we say it's locked, and away we go. There is an indicator in that GGA record. Jerry wasn't using it. I don't use it either. I just go the same way he did from the number of satellites, which seems to work fine. Then we get into the setup routine. Those are our definitions of all of our constants and everything we're going to be working with on that basis. And in setup, we're going to start the wire begin. We start the I2C bus. And we also attach an interrupt on interrupt 0. We're going to get it on a falling signal, so it's normally high, and when the slave wants to interrupt us, he'll take it to ground, bam, which is falling from the 5-volt input signal to ground, or 0, from a 1 to a 0. So the falling edge of the square wave, and pow, it'll interrupt the master. The master will do its thing and set that post, and then return to whatever else it was doing. Then we start our serial port. We do our monitoring and debugging with the serial port. We fire that up at 57,600. That seems to be a nice speed, and it doesn't get in the way of anything else. Drinking a little coffee here as I talk. Then we print out the start message. It's a GPS frequency standard version 8.0, and away we're going. And we initialize the LCD output, and we put the banner out, which is GPS frequency line 1 and version 8.0, and frequency standard, set cursor, version 8.0. Set the cursor again, put out the date, July 6th. It's really some other date now, but I change that every time I make up a new version. Then we do our little ditty here to play the Nebraska fight song. There is no place like Nebraska. That's all I ever knew. That song I never learned anymore. Okay, then we sit around here finishing that song. We clear the LCD, and we set our slave frequency initially. We call a routine there to set the frequency. We initialize it at the U-blocks frequency at 3.333 kilohertz. Then we display the actual frequency. We display it on the LCD. So we're all set up and ready to roll now. We fall into our main loop. And let's see if we get anything from the keypad. See if we have a key pressed. And if we do, we're going to have a custom key, and it's not equal to no key, so we're going to fall right into this routine, and we're going to issue our key click tone, beep, very short tone for 50 milliseconds. And we're going to print on the console, on the monitor, we'll print custom key, so that's another debugging aid. Then we're going to switch on custom key and to process case 0 through 9, which are the keys. And here we say if we're entering the frequency. If we're not, if we haven't keyed the asterisk so we know we're entering a frequency, we're just going to ignore it. But if we are entering the frequency, then we're going to say pick it up, multiply it by 10, stick it out there on the LCD, and keep it until we get finished with the entry. And sit here looping around. Next time, we're not going to loop right here, we'll break out, but next time through we'd have one digit, then we do the second digit, third digit, as long as the entering frequency is on, and we're entering 0 through 9. When we're through that, we break out, we look to see if we got an asterisk. If it's not a 0 or a 9, we say, okay, we're going to start the frequency entry process. So now here's where we set that switch, or the entering frequency, true. So now everybody knows we're entering a frequency. And we set our digit count to 0, our frequency to 0. We're starting with 0. Set our cursor, and we clear the LCD line 2 where we're going to be working on the frequency. And we indicated new frequencies to be entered. So it'll be terminated with the asterisk key, and in the meantime, we're just going to, the only thing it'll operate on will be the 0 through 9. If we come through here with the pound sign key, and we're not setting the frequency, why it doesn't make it won't pay attention to it. If you key the asterisk a second time in a row before you hit the pound sign key, it'll just restart the entry. It's like you entered the wrong frequency, you want to wipe it out and start over again, which works out pretty well. When you finally kick the asterisk and you go to the pound sign, it'll say, okay, we're done. Let's set up this new frequency, and we'll display it so the slave can pick it up and say, oh, I've got a new frequency, and send it off to the GPS module, who will reset his frequency. Pretty slick, all of it. Okay, here's where we get to do when we get out of those routines and we're done with the switch statement, we'll say, okay, if the post from slave and we're not entering a frequency, then we're going to say the slave interrupted us and has new satellite data for us, so let's go get it. Now, we're not going to go get that satellite data if we're busy entering a frequency. We're going to ignore it. It can interrupt us as many times as it wants. We'll only accept it once until we process it. So we know it's got new data there, but we'll say, oh, hang on to it till we're ready for it. We're not going to be ready for it if we're entering frequency data. But when we're not entering frequency, that entering frequency is false, then we'll fall into it and we'll say, okay, we'll do the wire request from the slave and tell him that we want to accept 2 bytes from him. We set satellites to null, and while the wire is available, we read it, get a data byte from the slave, and concatenate it to the number being received. So we get our 2 bytes of data, 0 through 99, if there are 99 of them, which I doubt. I don't think there's that many up there. I don't know. I'm not a satellite expert by a long shot. Okay, serial print the data from the slave. That's on our monitor to say, hey, here's what we got from the slave. More debugging help. And we print it out on the monitor. Set our cursor and display the sat equals indicator, and we display the number of satellites. And if the satellite number is greater than 0, we'll display we'll put L in the frequency status to indicate that we've got a lock status and our frequency is locked to the GPS, our output frequency. Else we say, with no satellites being detected, we say, whoop, there's danger here, that's unlocked, and you don't really know what that frequency is going to be. At least it's not locked to the satellite. Then we print on the serial monitor what's going on too, for debugging. And if you don't have the monitor going, well, it just ignores these things. There's no monitor hooked up. And we clear the number in case of no satellites. Put some more out there. We're doing a little bit of housekeeping here. Set the number of satellites on the LCD. Print the lock status. And get the hell out of here. Then we have our display actual frequency. This is the routine which displays the frequency. And first thing it does is display the battery voltage. That's the only time we really display the battery voltage anymore. It's when we change when we're doing this display actual frequency, which happens most of the time when we change frequency. No sense in looking at that battery voltage every time through, so we do that in an additional subroutine. And we do it whenever the frequency is displayed. Then we set up our frequency to display, and we display the new frequency on the LCD. And we do it in megahertz. This is the original code right in here from Jerry. We stuck with all of that. So it puts it out at megahertz, kilohertz, or hertz. And that's a pretty nice upgrade that he made to it. Then we print it out for the on the LCD, and we're done with that. On the display battery voltage, it's the same routine Jerry had, where it displays the battery voltage, looking at the 5-volt reference voltage, default reference voltage from the Arduino. And here's the post when the slave interrupts us. We come to this routine. This is our interrupt routine. And we say if a not post from slave, which means if we haven't been here, if we've been here before and we haven't processed it yet, we don't want to do this. I don't think it would hurt to do it, because we just turn the switch on again. It was already on, so big deal. But we don't. We say if it's not post from slave, which means it's a new one, we haven't processed it yet, we'll say post from slave equals true to turn it on. That'll tell the main loop we got some data there to go get. And it'll also tell us if we get interrupted again, don't bother to set it again. And the current interrupt will be processed. We're done. Bang, we get out of it at the end of that subroutine. And the set slave frequency that we call, which is called from a couple of different places. I believe, if I remember right. I'm screwing with this some. I'm not 100% on it. I have to go through it again. Anyway, we tell the slave, look, we got some new frequency data for you, and the slave will get ready to receive it then, and we'll write anything set frequency. We'll send the new frequency to the slave, then we end the transmission, and away we go. That's pretty simple, actually. It's not tough at all. And that's the master. The way the master operates. We'll take a look at the slave program next. And so there you have it, folks. Part 2, the master sketch, is now completed. And before long, if you stay tuned to this very same channel, same time, every day, almost, we'll come back at you with Part 3, the slave sketch. All right. Over and out for now. Thanks for joining me, folks. See you later.